because I've ordered the pizzas for 30, but I'm sure we all want to have the pizzas warm, right? Poor Simon doesn't get run over in a rush. So you just go straight into it, Simon. I might even skip your intro, and I guess we'll pick that up as you come along. LX Group, Simon. Actually, Simon, whilst he's getting going, actually founded the company. A little bit last time here. And director of LX Group, electrical engineering design house that specialises in IoT, which is Internet of Things, and M2M, or machine-to-machine solutions. He founded LX in 2006 with the intention of creating a team that had the expertise and resources to rapidly prototype innovative products. So Simon sees himself as a maker and hacker at heart, and brought his own skills to the embedded systems and product development specialists. I've only got one screen working.
Maybe turn it, I think it turned off.
Simon, I think you probably just launch into it if we've got one screen, or just we'll just keep pressing on, I think.
Alrighty, hey guys. Let's see if that comes up. If not, we'll just wing it. So, anyone here looking at doing hardware or currently doing hardware? Yes, no. Probably not many people. Okay, we've got one. Okay, alright, okay. So, this is probably not going to be very interesting for you then. A little bit of a show of hands. Anyone doing startups in the software space? Or okay. I'll tailor it a little bit because it's 2016. Now, 2016, hardware is actually becoming hot again. So I'm a hardware guy at heart. We build physical products, not apps. But I mean, we build apps because most physical products don't talk to an app. But physical products, like an internet-connected toothbrush, or say it goes on a cow, or a device that goes with a Black Hawk helicopter, or a medical device, those kind of things. A lot of startups rightly avoid hardware. Hardware is hard. Fitbit, the $7.8 billion success story, nearly failed 7 times because of hardware, because it's blooming not as easy as you want to think it is. I envy the startups who, they build an app, they mock it up, they get it out there, they do some user experience stuff, and suddenly their company scales to infinity and beyond, it's worth an absolute fortune, and they haven't had to ship something, they haven't had to go to a manufacturing facility, they haven't had a product recall, they haven't had grey market components that's totally screwed up that batch of 2000, right? So Chris, IP, and then with Rob, software, user experience, MVP kind of focus. What I want to talk about, or looking to talk about tonight, is just about rapid hardware prototyping. So just pretend for a second you're interested. And I think the reason why I'll try and get you interested in this is because there's a real paradigm change that's happening. So because a lot of you are software guys for this startup, for the next one you might have some hardware components. And I'll tell you why. When the computer first came out, it was big, power hungry. It was very expensive, didn't do much. It might count a census, but that's about it. Now, computers are tiny, they're everywhere, they cost very little, they run for 10 hours, and so suddenly you've got market acceptance to go. Same thing with phones. When a bag phone came out, big, clunky, didn't do much, very expensive. Now, everywhere because those problems have been solved. The same thing is happening with physical devices. We are instrumenting the physical world, whether it be your garden or your business, your car, your toothbrush, whatever it might be, your dog. We're internet enabling everything. The reason we're internet enabling everything is because with feedback, with control loops, like I'm kind of an engineering guy at heart, right? So with control loop, with feedback you can improve pretty much any process. Right? Whether it be health or whether it be the way in which your business runs. We currently run businesses a little bit like driving a car where you look at the road every 30 seconds, right? It's going to be a bit of a bumpy ride. You can optimize any business, any process, anything if you get a bit more information and you run a nice algorithm over it and make some intelligent decisions. That's why hardware is going to everything, because at the moment, when a coder sits there saying, I need to know the status of the door or the temperature or the light or the soil moisture or whatever it is, they go, start an API call for that. I just want just to be able to read that, but I can't because I need a bit of hardware. So, point is, hardware is now becoming cool. Hardware is becoming ubiquitous. It's going to everything. So it gives us the information that when we have an app like, it's Fitbit or something, we actually can talk to that. Now, it looks like the slides haven't come up. That's totally cool. But what I might do, I can remember it's just that there's some few visual aids that would have helped a little bit. So, if you need to build hardware, right, there are a few different options you have in front of you. One is to use rapid prototyping tools like Arduino, BeagleBone, Raspberry Pi. Do any of those ring a bell? Right? Great, okay. A lot of these use a stacking methodology, right, where you get a base board processor and you stack things on top of it. So let me give you an example. If you wanted to build a dog collar, like a GPS dog collar to find where your dog is, you would probably get a processor board, you would stack on top of it a GPS board, you would stack on top of it probably a lithium polymer charge management circuit or something, and you probably put a 3G backhaul, right? So you can find out where the dog is, you can get the data back, and you can have a battery that will manage the process. The problem is, it ends up being this high, this wide, this long. You show your investor, he kind of looks at it and goes, or she, you've got to figure a way to go there, right? And the problem is that hardware is hard, so investors run screaming for the door. No one wants to invest in hardware, or at least that's how it has been. So if you want to get some hardware done quickly, that's a really good place to start. But you need to really understand what your objectives are. So we see a lot of people becoming really, really obsessed with some weird criteria, right? And I put, whether it be raising, needing a prototype for a government grant, Kickstarter campaign, getting management buy-in if you're in a large organisation, or raising capital, getting some user experience, so some user trials, some input from customers, pre-sales, whatever the mix of those things are, there are these different reasons why you need a prototype at various points before you go and build some real commercial hardware. There are these different objectives. But I find that people get very kind of confused as to what those objectives are. They're kind of wanting to verify that technically something works, and at the same time being really caught up on the unit price, for example. Or they want to check the GPS location accuracy of something, but they're really caught up on the size, for example. Right? Now, that is a really, really big error to make, because you can spend $1 million on some hardware, you can spend 10 grand on some hardware. You can spend $1,000 sometimes on some hardware. And if you can very clearly delineate in your own mind what your objectives are for that particular prototype, you can cut a whole heap of development effort out. So although there is these different goals or objectives, I tend to put clients or people developing hardware into two camps. Are you raising money, or you're building a commercial product? Very, very different things. If you're raising money, what you really want to do, talking about risk reward, is you want to spend the minimum amount of money to get the maximum outcome, to prove the things, to do risk the venture, so that when you're raising capital, you've essentially maximised the value by that point in time. So that first step really, sometimes people, if they're looking to raise money, we call them launchpad customers, so they're just trying to raise capital. You're doing things like proving, is it technically feasible, right? Now, often you know that it is. Often you know that the technical feasibility thing, it's just a hurdle that someone who's non-technical wants to see to make sure that, okay, it works. Often it is just a demonstration of the idea. Some people find it hard to actually grasp an idea until they see it working. There are these kind of things. For those kind of things, you can get away with some hardware tools like Arduino or something that can actually just quickly be plugged together, coded up, so it's back in the software world, which is good. You kind of get rid of the hardware component quickly and do something. But the second you want to go to a commercial product, you've got a few problems. It's usually big, it's usually consuming too much power, so that battery life of 2 weeks that you want to tell your market is now 4 hours. It's usually too expensive. If you wanted to build that in high volume, it would be $300 instead of 20. It also can't be certified, so you can't take that prototype platform and sell it in Europe because it won't pass the CE testing. If anyone, just a little, CE testing, they zap it with 9,000 volts to make sure it still works afterwards. There are certain things you need to do to make sure it passes that test. So there are these problems you have when you the way I see it is a little bit like, if you're building a house, you get a block of land, you can put up a tent, right, and that gives you some temporary accommodation. At the end of the day, you're going to have to pull that tent down. It's kind of a waste of time and money. If you can build the scaffolding for the house just right, then what you can do is you can later add features, functionality, and refine it. So we look at it as, are we building a temporary house? So if you've raised your capital and you're now in the space where you're building a commercial product, the question is, with hardware it's a little bit different to software because once you're building a commercial product, you really do need to plan it right from the outset. Although agile hardware is certainly something that is becoming more possible because of the low cost mechanisms for actually building some boards, right? So 20 years ago, just to do one circuit board was a huge amount of effort. And like you'd tape it out manually, it's horrible. Now you can get some prototypes for $50 kind of thing. So you can actually do agile, but you need to be actually using the right key technologies and everything that are going to be used in your end application. So what we have been doing, and that's something I wanted to share with you a little bit today, is we've been developing a platform that makes it easy to build commercial hardware, but on a launchpad kind of budget. And let me explain how that works. Every product looks different. The Fitbit looks different to the toothbrush. It looks different to the monitoring system on a gas pipe. It looks different to a device in a car that tells you whether you should drive slower or faster. All these things look really different in your dog collar. They look really, really physically different. And the thing about the Internet of Things is, for many years, businesses have been built and software has been designed around existing bits of hardware. So you've got a computer where you're writing an application for a computer. You've got a phone where you're writing an app for a phone. But now that everything's going into the hardware domain, it's going into all the things. What you're finding is that the things have to be different. Like, gone are the days where you just have this one beautiful platform and it goes in everything. Like, in the Internet of Things, one of the challenges is there's lots of different things, and those different things have very different requirements. So if you're looking at the different applications, the dog collar, the toothbrush, whatever it might be, when you get under the hood, there are some very, very common components, right? It needs a power supply. Now, when you look at a power supply, there are only so many options, right? You might have inductive charging, so if it's a device that you just throw on a plate, or maybe it's a hermetically sealed device for medical, for applications, you might have inductive charging. It might be a device that's out on an animal, so you might have a little bit of solar assist, or it may be in the garden, so you get a little bit of solar panel that's kind of feeding it. You might have a device that just plugs into a 5-volt USB charger, for example. And sometimes you just have something that just runs an alkaline cell and that's it. It's just disposable, you replace battery. So when it comes to power supplies, there are only a small number of options. Right? It's not 20, it's like, there are, but in terms of 80% of applications, 90%, there's like 3 or 4, really. You have some processing. Right? The device is intelligent, it needs to be programmed, and the rule of pretty much what processor you put down is just a little bit bigger than you need. Why? Because everything costs money. Hardware, there's not much money in hardware. You're trying to reduce your cost. So really, when it comes to little embedded processors and most things, there's not much. There's a few different options. Kind of think of it like t-shirt sizes, small, medium, large. So power supply, processor. You then have a few sensors. Right? So if you look at Fitbit, you might be looking at the activity level. So you've got an accelerometer. Or if it's a dog collar, you might have a GPS receiver. You might have, for some things, if it's a wine cellar kind of temperature and humidity monitor, you might have temperature and humidity. There are only a number of sensors that go either on the board or they go off the board. So off the board could be an agricultural soil monitor probe or a wind direction kind of gauge, right? So sensors, there's some that go on the board and some that just go off you know, on a wide network. You've then got some communications. Bluetooth, Wi-Fi, 3G, LoRa, Sigfox, Taggle, AMP Plus, if you're linking up to say, you know, sporting devices. Again, there's only so many options. You've then got sometimes some actuators. So actuators are things that control something. They control whether a door is open or closed, or a remote motor is on or off. So sometimes you're controlling something. You get all this, you wrap it up into a little board, and you connect it to the cloud. Then your software guys are happy because you've got a little API, and you're like, oh great, I can now control the door, I can now read the temperature, I can now do that stuff, right? So let's look at that hardware subsection. What has been done traditionally, other than build from the ground up, which trust me, like building from the ground up is just a nightmare. Like it's seriously horrible. You know, you can do it, it's fine, but you've got to have a really good hardware engineer. It's very easy to make something work, it's very hard to make something that will go into millions of units and not come back to you, right? So building from the scratch, possible. Could run a seminar on that for like a day, totally there, but you know, it's hard work and it's high risk. So what has been done previously is this stacking stuff, right? Where what you do is you get your processor board, your GPS shield, you click it all together, the things that you need. And it's like Lego. But the problem is power consumption, size, unit cost, ability to get certified in different countries, that kind of stuff. So you very quickly hit a wall. And that wall means I now need to execute a custom hardware development exercise, which means you need money. You're going to bleed it. You know, you're going to need some money and then some more. What we've been doing is taking a different approach. If you could imagine everything you could ever want on, like, you know, the size of a cube of sugar, for example, all those different things, and it's already certified, it's saying it has ultra low power consumption, ultra low unit cost, and what you're doing is actually just subtracting the things that you don't need. Right? That's what we're doing. So it's a rapid, and we're a spin-off out of a consultancy, right? So we're a consultancy who sees the problem, and we're a spin-off coming out of that to try and solve this problem, which is kind of funny because we're competing with our own business. It's like a, you know, a spin-off that kills the father kind of thing, right? It's just, so what we're doing is, I'll give you an example. If you had an Arduino shield that was the size of a credit card, and it was a lithium polymer charge management circuit. So what that means is lithium polymer batteries, the batteries that are in most of your things, it's a charge circuit for that. So that is seriously an Arduino shield that's the size of a credit card. The Arduino shield, to click onto an Arduino, it has a bunch of pins, right? Now these pins are about 1.5 milliliters by 1.5 milliliters each, and there's probably about 15 and 15 like rows there just to connect the shield inside the credit card. We've used technology on our series of IoT cores that is more like that you would find in an iPhone. It's highly miniaturized, it's very difficult to manufacture, you know, initially. But our lithium polymer charge circuit would actually be 1.5 mils by 1.5 mils. My point is that entire circuit is the size of one of the pins on that connector that adds that shield. So what we've done is put everything down, and we've made it so you can actually cut these boards. Just cut them. You cut off the bits you don't need, and you don't populate the sections you don't need. So you get your unit price down. Now we're not there yet. So I'm kind of pitching utopia where we're going. We're not there yet. We've still got a way to go. But we've brought it down into these three cores: a wearables core, a long-range sensor core, and a cellular core. So if you want to build things like a wearable, like a long-range base station, like for LoRa, like Internet of Things networks, sensors for ag, industrial, smart city, all that kind of stuff. That's the approach we're taking. It's about subtraction, not addition. So that, I just time check with the pizza. So I think we're going to be interrupted by pizza very shortly, and I'm sure what happened at that point in time, everyone's like just going to run over there. So to try and wrap this up, the main points I think I'd make would be, one, when it comes to hardware, building custom hardware, one, make sure you have to do it. Right? It is hard, it is expensive. If you can get something off the shelf and you can use that, great, do that. Go back to the software world, because that's really, it is a painful process. If you have to do it and you have to build prototypes, use rapid prototyping techniques that are available today. But be very focused on what you're trying to achieve. So don't get obsessed with certain criteria like unit price when you're just not there yet. You want to validate the market, not actually prove that you can make it for $5. That's a different step. 3, not trying to pitch our stuff, but rather just saying we're in an early kind of launch phase. So if anyone ever did want to look at it, we're happy to kind of open the kimono a little bit earlier than when we launch. And 4, I think I would say just if you're doing hardware, get some good advisors around you who've done hardware before, because it is hard. And finally, don't forget the industrial design. So very quickly, industrial design is the bit that wraps around it. It's the injection molded parts that actually make it look sexy, right? So we think, as an embedded systems guy, we think the board's really sexy. We think it's hot, but yeah, the user sees the enclosure. Industrial design, very different electronics. There's some great teams here in Sydney who you can work with to actually build enclosures, injection molded parts, anodized aluminium, like what you would see on an Apple computer, for example. So pizzas are here. Thanks very much for your time. Really appreciate it. Sorry about the slides.
Thank you, Simon.